Hello. We are moving on today in our unit to talk a little bit more about functions. So at the very beginning of this unit, we talked a lot about functions. That was our 4.1. And then 4.2 was like, okay, we're going to apply some of the things that we know about functions for linear models. And then now we need to go back to the idea of functions, but more specifically, inverse functions. Inverse functions are going to be something that just continue to pop up throughout this year. And so this is just kind of the place where we have to kind of squeeze it in is when it first kind of starts showing up, which it will with linear functions. So inverse functions are functions that undo other functions. So it's a relationship between an original function and the inverse function. And their relationship is that they like undo each other. Like addition undoes subtraction, like multiplication undoes division. It's that same idea, but now instead of talking about operations, we're talking about functions. And so we're saying, okay, this function undoes whatever the first function did. And the main idea with that is that everything flips around, everything switches in order for it to undo it. What I mean is that all of your inputs become outputs, and all of your outputs become inputs. All of your x values now become y values, and all of your y values now become x values. And that's the main idea that I want you to remember, hence the image, with your inverse functions, is that it's just everything flipped or everything switched between two functions. There are a lot more things that we can get into with this unit, but we will never, ever, ever learn how to actually find the equation of the inverse. You will never be asked to do that in a generic way. You might be asked to like a bunch of questions that could lead to you finding the equation of the inverse. That's never something that you would have to do. And you never have to learn how to verify that two equations are inverses. All you need to do is focus on what we're learning today, and that's the main idea of what you are responsible for in regards to inverse functions for the IB. Okay, so going back to what I said about everything being switched between a function and its inverse function. So inverse functions are a pair of functions such that the domain of f of x now becomes your inputs become your outputs. So your domain is now the range of f to the negative 1 of x. Inverse is f to the negative 1 of x. That is how we represent an inverse of a function. Now, realize that we do have properties that involve exponents of negative 1, right? We've talked about that in the past where something to the negative 1 power is 1 over that thing. That is not what this negative 1 represents. I know it looks like a negative 1 exponent because I guess it is in the way that it looks and the way that we write it, but it doesn't behave like exponents actually behave. This is not 1 over f of x at all. It's just implying that this is the inverse of the original function. That's all it's saying. This is the notation of how you reference inverse functions, but it's not actual exponent properties at all. So just make sure that you're aware of that. Okay, so the domain of the original function is the range now of the inverse function versus the range of the original function now becomes, try it out on your own, the domain of your inverse function. So everything is just flipped. Let me show you how that looks. If I were to draw a mapping diagram where this is A and this is B, and they are brought from one to the other by the function f. I did 1, 2, 3, 4, and then 6, 12, 18, 24. And I would say, okay, 1 goes to 6, 2 goes to 12, 3 goes to 18, 4 goes to 24. If I were to then talk about the inverse, I could even, with a new mapping diagram, have A and B. And it's now, instead of having A go to B, it's just saying, oh, well, then now B is going to A. That is the inverse of a function, is you're just going back to the original. You're undoing what you have done. So you would still have 1, 2, 3, 4, but notice, implied by this arrow, the output now are your 1, 2, 3, 4, and now your input is 6, 12, 18, 24. So 6 is put into the inverse function and gives you 1. 12 goes to 2, 18 goes to 3, and 24 goes to 4. So talking about functions and their inverses, we have this idea of everything being flipped. However, just like with any other relation, not all inverses are functions, but we do want to talk only about inverse functions today. So note, a function has an inverse if and only if it passes the horizontal line test. So we've talked about the vertical line test. So for instance, if we are to look at this graph right here, and I would say, is this graph a function? And you would say, oh, vertical line test. I'm going to imagine a straight line going across this graph. As long as it doesn't hit the graph more than once, it is a function. So we do that and we see it's a function. Now, if we want to know, is the inverse of this graph also a function, you now, instead of doing the vertical line test, do the horizontal line test. If it passes the horizontal line test, where you imagine a horizontal line going up and down now, this relation, this function, if as long as that horizontal line does not cross the graph in more than one place at one time, then its inverse would also be a function. Realize that a parabola does not have an inverse function because it does not pass the horizontal line test, only the vertical line test, because the inverse of a parabola would look like that, which is not a function. We'll talk more about graphs of inverses at the end of these notes, but that's something to keep in mind. So a function has an inverse if and only if it passes the horizontal line test. If a function passes both the horizontal line test and the vertical line test, it is called one-to-one. It's a one-to-one function or a one-to-one relation. And our mapping diagrams up here represent that one-to-one representation of a relation. Every single input has one output, and every single output has one input. We're not having multiple inputs going to the same output, right? So for instance, a horizontal line would have all inputs going to the same output. At x equals -2, you still go to the same number as when x equals 5. But it doesn't pass the horizontal line test, so it's not a one-to-one relationship. So functions and their inverses are also functions if and only if it passes both the horizontal and vertical line test. In other words, if it's one-to-one. So there's all of this like technical terminology, but that's the main idea of if it passes the vertical and the horizontal line test, then the function and its inverse is a function as well. Then both the original and the inverse are functions. Okay. So let's talk for a second about this graph right here. I'm going to call this f of x. This is the inverse of f of x, and I would call this f to the -1 of x. So for f of x, I'm going to create a table of values. I notice that at x value 1, I have a pretty nice, easy y value. So I'm going to do 1, 2. And then I notice with this graph, I also have a nice point right here, which has an x value of 2 and a y value of 3. And then I notice that this is also a really nice point, which has an x value of 3 and a y value of 6. So here are, and this is an example of 3 points that are on the original function f of x. When I say that everything is flipped, I mean that everything is flipped. If I wanted to find the new points of my inverse function, all I have to do is take each of these original points and flip them. My y now becomes my x. My x now becomes my y. And check it out. Going to your inverse, 2, 1 is a point on the inverse. You can do the same with any other point that's on your original function, right? 2, 3 becomes 3, 2. 3, 2. It's on the inverse. 3, 6 becomes 6, 3, which is on our inverse. Okay, so these are the generic general relationships between a function and its inverse. So let's talk about some more IB ways that we are asked to handle it. Example one's not necessarily IB level, but there are definitely, like, when we have those large problems that we're being asked to solve that have parts like A, B, C, D, all the way down to H, a question like this is very typical to have at the beginning of those types of problems. Just kind of getting your feet wet in the problem and saying, hey, find or write down the value of f of 2, or write down the value of f to the negative 1 of 9. These types of questions do show up on IB problems. They're just typically like the first step of very many in order to talk about what the IB wants you to talk about in regards to that problem. Okay, so let's just practice the like basic relationship of graphs and inverses and how to find values. So this is only the graph of f of x, and it's saying like, hey, find values of f of negative 1, and we don't actually have the graph of f to the negative 1 of x. We only have the original one. But if we use what we know about graphs and their inverses, we know that we can flip some of our input-output relationships in order to solve for things like this. But first, let's do something easy. We're going to find f of 2. I believe you can find f of 2 on your own. That's something you've been doing since middle school. So finding f of 2 means that I go to an x value of 2. I go up until I hit the graph. Once I've hit the graph, I go over to the y value and say, what is the y value at that point? So here is 2. The y value, if this is 2, 4, 6, it's halfway between, so that would be 5. So f of 2 equals 5. It results in the point 2, 5, an input of 2 and an output of 5, an x value of 2 and a y value of 5. That's all it's saying. So that's the first answer. F to the negative 1 of 9 equals question mark. For problems like these, I recommend flipping them and say, okay, well then if it's f to the negative 1, then I can do f of, so talking about the original instead of the inverse, and then just flip my inputs and outputs. That means that it would be f of question mark equals 9, right? If it was 9 question mark in regards to a point, to talk about the inverse or the original, if we're talking about the inverse, then we would just switch those out. That's all an inverse is just flipping your inputs and outputs. It's just a flip every single time, okay? So now I can look at the graph and say, oh, what this question is asking me is if I have an output from my original function of 9, even though it looks like an input when we're talking about it in an inverse sort of way, it's really an output from the original function perspective. I would say, okay, if I'm looking for an output of 9, then what would have been my input? So I go to the y values, find 9, which is halfway between 8 and 10, go over to my graph, find that point, go down to the x value, and I see that it is 4. F of 4 equals 9. So to fully answer this question correctly, I would say f to the negative 1 of 9 is equal to 4. So this would be the point question mark 9, right? That's your thought process there.